Hi, this is a video for COMP345. This is a presentation for assignment number 3. So this is, as I said before, this is going to be the simpler, I might say, of the 3 assignments. So this video should be kind of short. So let's go to the assignment handout itself. Okay, let's go to the start. So again, this is a team project, same teams. The deadline is December 3rd. And then this is for 10 marks, 10% of your final mark. The specific requirements or design requirements are all the same as for the 2 first assignments. Here I've added that you must have the game logging as part of logging observer and .cpp and .h. All of the implementation of your orders must all be in the orders and so on, as described in assignment number 1 and number 2. So you're not allowed to change that for assignment number 3. Again, for the parts of assignment number 3, it's going to tell you in what parts, what files these parts need to be implemented. In this assignment, there are only 2 parts. So as I said before, this is going to be probably I couldn't say this is a simple assignment, but at least there's a less amount of work to do. Okay. I do this because I know that sometimes, in most cases, unfortunately, a prof gives projects, and then the difficulty or the load is going, it's heavy toward the end. So I'm trying to give you a break somehow on the last one here. So what is the different parts? First, strategy pattern. So I explained that if you saw when I gave the lecture on strategy pattern, I actually explained how it should be done. So that's going to be somehow a repeat of what I said then. So here, essentially, what you have to do is to add different kinds of players. So the different kinds of players are, first of all, first there is one kind of player that is the human player that requires user interaction on the keyboard. So that's the human player. All the other players, the other 4 kinds of players, they are computer players, which require 0 user interaction. Okay, very important to understand. Human player, the user is going to interact with the software on the keyboard. Whereas aggressive, benevolent, neutral, and cheater, there's no user interaction. 0 user interaction. Now, essentially here, what's happening is that, as I will explain later, you have to use the strategy pattern to implement different behavior for the players. Now, here, let me describe what are the different behaviors. Essentially, here, these different behaviors are, by behavior, what I mean is that they're going to have to make decisions as to what orders to create, and especially if they are creating an order that targets a territory, that they will use different criteria to choose their target territory. For example, a certain player might target when they want to deploy, they might target their more powerful country, whereas another player might target the least powerful country, or a country that has less or more armies. Okay, so that's what I mean by the behavior that changes is as to what kind of order they are creating and what territory they are targeting when they're actually making these decisions as to what order to create. So human player essentially will make decisions by relying on the user. So this is going to be interaction with the keyboard with a human person that is going to decide what order to create and what territory to actually target from the orders that they create. In fact, even though that may seem more simple, you will quickly see that there is actually much code to be written here, because it requires that you, for example, if you have the human player, then you will have to, on the console, tell the player what kind of order do you want to create and give a list. Say 1 is a deploy, 2 is an advance, and then maybe you have to list the cards that the player has. So which one do you want to play? Let's say they select deploy. Then you have to ask the player, what territory do you want to target? And then give them, for example, a list of territories that can be targeted, and they will choose that, and then they will create the order deploy on the territory that they chose. So for each of the different kinds of orders, you will need to have some kind of code, hard-coded interaction that enables you to create an order of that kind. Then the aggressive player. So the aggressive player, again, the human player is the only one that will require user interaction. All the others there's no interaction. They make decisions by themselves without interaction. Aggressive player. So that's a computer player that focuses on attack. So as the name says it, this one will want to conquer the world. Okay. So what it does is that it deploys and advanced armies on its strongest countries. So it wants to reinforce, to deploy armies on their country that's already containing more armies, because an obvious strategy for somebody who's aggressive is to have more power and basically attack with the more power that they have on a single point. Okay. Very typical strategy for a game of this kind. So it's going to want to deploy on a single country and then move all their armies on this country. Okay. And then it will want to attack with this country as much as possible until they can't attack anymore. Then the benevolent player is kind of the inverse. The benevolent player, first of all, will want to never attack. And what it wants is to protect its weakest countries. So it will deploy on its weakest countries. If there is a country that has more army than the other, that is adjacent, is going to want to move armies to the weaker one as to protect them. Okay. That's essentially what the benevolent player is doing. So right away, you see that it's impossible the benevolent player can actually win the game. Well, we may want to discuss that later, but let's say extremely improbable that the benevolent player would win the game. Neutral player. So we saw what the neutral player, or the concept of the neutral player was before. When you play the barricade order, actually creates a neutral player and gives this territory to the neutral player. Well, here we have to define what is the neutral player doing. What the neutral player doing, what the neutral player is doing is nothing. You're calling issue order on the neutral player. It does nothing and just returns. It does not create orders. Okay. Here I'm introducing an interesting aspect, because if you're using the strategy pattern, then you should be able to change the behavior over time. Here I'm saying if you are the neutral player and another player attacks you, then you become an aggressive player. Then there's the cheater player, because I introduced this one because it creates a player that is very likely to win. If you have only these here and you run a game, automatically you'll see that very often it does not finish. Okay. The cheater player is there to, if you run a game, you put one cheater in the game, very likely that it's going to finish. It is going to finish very quickly. What does it do? The cheater player, the name says it, it's a cheater. It doesn't care about the rules. So what it does not create orders. Rather, what it does is that it automatically conquers all territories that are adjacent to its own territories once per turn. Well, of course, if you do it multiple times per turn, it's going to win on the first turn always. So in order to make it more interesting, then the cheater can do this only once per turn. So you call issue order on the cheater player. It's going to conquer all the countries that belong to an enemy that are adjacent to his countries. And then it's going to not issue any order for the rest of the turn. And of course, it's going to wait for the next turn. Then it's going to do the same. And of course, in a few turns, it's going to conquer the whole map. You see here, cheater player, it essentially conquers the world without creating any order. So that's about it for as far as functionalities that you have to do. So there is some drivers that I'm asking you to implement. You must have a driver that demonstrates that different players can be assigned different strategies that lead to different behavior using the strategy pattern. Second, the strategy adopted by a player can be changed dynamically during play. For example, when the neutral player is attacked, it becomes an aggressive player. Well, you can also hard code in your driver to show that you can have a player change his behavior. Third, human player makes decision according to user interaction, and computer players make decision automatically, which are both implemented using the strategy pattern. Your class, human player, is just one subclass of the player strategy, as I will explain later. It's not something different because it's human. It is following also the strategy pattern. Here I'm listing all the conditions that must be there for this to actually be following a strategy pattern. Right away, if I'm telling you as a developer, okay, you have to implement different kinds of players, different behaviors of players, most of you will actually think, okay, I'm going to have subclasses of players. Well, right away, you would be wrong because there's no such thing as a subclass of player if you're doing what I'm asking you to do. Essentially, you have to use the the strategy pattern. So how it works is that your player class, your existing player class in black here, what you need to do is to include in it a object or pointer to a player strategy object. So you need to create this new class player strategy. And then you will create subclasses of player strategy, one for each of the different kinds of behaviors. So this here are all behavioral classes that implement the behavior of your player. And there's only one kind of player. There's no subclass of player. Then in your player, you already have issue order, to attack, and to defend. So these are the methods that you call if you want the player to make a decision as to what order to create. And then when they want, for example, to create a deploy order, as we discussed before, how does it decide what country to target when you call deploy? It will actually call to attack, to defend, and then it will take one of the territories in the list of to defend and then target this territory as the target of the deploy order. So that's how the player makes decisions, by calling issue order that itself is calling either or both of to defend and to attack. Now here what's going to happen is that whatever you had already in issue order and to attack and to defend, it's going to be replaced by an actual delegation to the issue order of the player strategy. So when you will call issue order of the player, it's actually going to delegate or call the method issue order of the player strategy object that is inside of the player. And then depending on what specific subkind of object that is pointed to by this pointer here, then it's going to call, for example, issue, if the player strategy here is, for example, aggressive, then when you call issue order, it's going to call issue order of the aggressive one and then execute the code that you have here. thus making decisions according to the aggressive strategy. Then you can actually change later on what strategy is being pointed to here, for example, to neutral. And then if you call issue order again, then it's going to call issue order of the neutral, which is then going to do nothing. Okay. So that's how it should be organized if you are actually following the strategy pattern. Next thing, or the last thing, because there's only two parts here, is what I call the tournament mode. So here, what I want you to do is essentially to implement a way that the user can actually tell the game to actually run some kind of tournament, to specify a certain number of players that are going to be doing a certain number of games, iterations of games, on different maps. Okay, so you're literally doing a tournament and you're trying to determine who's going to be the person or the player that wins the most games at the end. Okay. So essentially what this is going to do, it's going to use your main game loop as you have it already. It's not going to necessitate that you change much in your code, but then it's going to enable you to actually run a tournament like this using the code that you already have. And as I will show you, it hopefully with as less changes in your code that you already have as possible. So how does it work? So essentially, what's happening here is that during the start game state, when you start the application, the game engine starts in the start state before you even load the map, if you remember. Okay. So in this state, I want you to add a new command that is the tournament command. So when you start the application, you'll be able to type the first command is tournament, blah, 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 like this, where you specify what are the parameter of the tournament that you want to play. Right. Now you're going to enter, allow the command processor to process this command. Then it's going to essentially set the stage for the tournament to run. And then it's going to actually run the games one after the other. Okay. It's going to be some kind of loop inside that's going to be added above the entire game loop that is taking care of executing all of the games. There's different ways of doing this depending on how you have already organized your code. So you go to the start game state. Right at the start of the execution, the user is able to enter this command here. Now, what are the parameters of this tournament? So first parameter is M. So in M, you give a list of files. So just like when you loaded a file, you had to give the name of the file. Here, this is essentially -M and then a list of files. So these are all the files that are going to be, all the maps that are going to be used in the tournament. Okay. Then you have, and then you have from 1 to 5 maps. So you can run a tournament on 1 map or can run a tournament up to 5 maps. So that's for the first parameter. And then the -P, the second parameter, is the different players. So different players are from 2 to 4 players. And the players are all computer players. You cannot run a tournament that includes a human player. Okay. What I want is that it actually runs all automatically, that you don't have to do anything. You just say tournament, blah, 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 and then you click enter, you press enter, and then it basically runs all the games that you specified in your tournament command. The second one is a number of players. So, and then they must all be computer players. So you have a list of players. For example, you could have, as I mentioned here, aggressive, benevolent, neutral, cheater. You could have also 2 different aggressive players and 1 cheater, as you wish. And then the third parameter is the number of games being played on each map. Okay. And then the last parameter, D, is the number of turns, the maximum number of turns for each game. Because as you will see, if you don't have that and you don't put the cheater in a tournament, you will quickly see that if you have aggressive, even if you have aggressive player in a game that you run, you will quickly see that the aggressive player seems like it's going to win, but it's going to get stuck in some kind of flaw in its own reasoning. Okay, we can discuss that later. The effect is that if you don't put a cheater, then it's possibly going to run forever for any game that you run. So that's why here I have set the parameter, which is the maximum number of turns for each game. The idea is that if you run the game and you reach, for example, you say the maximum number of turns is 10, the game will run. Then after 10 turns, if there's no winner, then it's going to be a draw. Okay. So you put this command here, and then the game is, your game engine is going to have a special piece of code that is going to somehow wrap the execution of your game into a loop that is going to set the parameters of the game, and then will start the game as it was before. Okay. As far as the core main game loop of your game is going to stay in exactly the same. Okay. The only thing you have to add is kind of this wrapper loop around the main game loop that actually runs the tournament if tournament command is being chosen, or tournament mode is being chosen. So that, for example, if you you write this command here with M being map 1, map 2, map 3, P, the number of players, is aggressive, benevolent, neutral, cheater, G, which is the number of games, is 4, and D, the maximum number of turns is 30. Then at the end, it should output to the log file a table or the results like this. Okay. Example, there is essentially what it's saying is that for each map, there is 4 games that are going to be played with all the same players. Okay. So map 1, game 1, map 1, game 2, game 3, game 4, and then you go to map 2, game 1, 2, 3, 4, map 3, 1, 2, 3, 4, and all with the same players. And then here you essentially write down what was the winner of the game. Or if it's a draw, then you write draw. So, okay, so this involves, well, of course, the driver here is quite simple. So essentially, when you must show that when you type the tournament command, that the tournament will start, and that eventually it will end, and then this will actually be written into the file at the end. This should be implemented. Well, first of all, you must add this command here, which should be implemented inside of the command processor, as well as the code, the loop for the tournament itself should be implemented in the game engine. So that's it for that. So you see that it's not to say that it's a simplistic assignment, but I hope you see that this is possibly the one that is the lighter of the 3 assignments. So that's it for this presentation. Bye-bye.